Hello students, we are going to start a chapter Force and Law of Motion. A force is that physical quantities which causes or tends to cause a motion in a body at rest or stops a moving body or changes the direction of motion of a moving body or changes the size and shape of a body. Thus, a push or pull on a body is called force. To understand the meaning of the term force, let us see some effect of force. Number one is a force can change a stationary object. Second one is a force can stop a moving object. Third one is a force can change the speed of a moving object. Fourth one is a force can change the direction of a moving object. And last one is a force can change the shape and size of a body. There are two kinds of force. Number one is balanced force and second one is unbalanced force. What is balanced force? If the resultant force of all the forces acting on a system or a body is zero, then the forces are called a balanced force. Thus, balanced force produces zero acceleration. It should be noted that balanced force may changes the size and shape of the body. As for example, we press a rubber ball by our hand applying the equal and opposite forces, the shape of the ball is changed. This is balanced force. What is unbalanced force? If the resultant force of all the forces acting on a system or a body is not zero, then the force are called as unbalanced force. Unbalanced force can change the state of rest or uniform motions or direction of motions. Thus, unbalanced force produce acceleration in the system or in the body. The resultant of unbalanced force is always greater than zero. Now, the next topic is Newton's law of motions. There are three laws of motions. First law of motions, second law of motions, and third law of motions. Now, the first law of motion is a body continue in its state of rest or uniform motion in a straight line unless an external unbalanced force is applied on it to change that state. Now, next topic is momentum. The momentum of a body is defined as the product of its mass and velocity. Thus, it is expressed by P. Thus, momentum is equal to mass into velocity. The SI unit of momentum is kilogram meter per second. That is, P is equal to kg meter per second. Next law is Newton's second law of motions. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force and at a place in direction in which force act. That is, F is equal to change in momentum divided by time taken. After calculating this expression, we will find F is equal to m into A. Thus, force is equal to mass into acceleration. Its SI unit is force. Newton's third law states that to every action there is an equal and opposite reactions. When a body A exerts some force on another body B, then body B also exert equal and opposite force on body A. Out of these two forces, one is known as actions and other is known as reactions. As for example, a swimmer pushes the water in the backward directions, that is action force, and the water exerts a force on the swimmer, that is reactions force, which pushes him forward. Next example is when we walk on the ground, then our foot pushes the ground backward, that is actions force according to Newton's third law of motions, and equal and opposite reactions act on the foot by the ground. Thus, ground is in turn exert a force on the foot, that is reactions force, pushes the foot forward. Our next topic is law of conservation of momentum. When two or more bodies act upon one another, their total momentum remain constant, provided on no external force are acting. Momentum is neither created nor destroyed. That is, total momentum before collision is equal to total momentum after collision.